Just a reminder here from geometry about special right triangles. Here's a 45, 45, 90 triangle. And if we consider that this triangle is drawn in the unit circle, then the hypotenuse is 1. And because it's usually the legs times the square root of 2 to equal the hypotenuse, to find the legs instead, to go backwards, we divide the square root of 2. So we would have 1 divided by the square root of 2, which gives us a square root in the bottom of our fraction. We rationalize it, which makes the legs square root of 2 over square root of 2. 30, 60, 90 triangles is like half of a 60, 60, 60 equilateral triangle. So therefore, in the equilateral triangle, all 3 sides are congruent. So if we split that in half, the side that's left from the equilateral triangle is the hypotenuse, or the 1 radius in our unit circle. And one of the other sides that's been split in half from that original equilateral triangle is half of that. And then the third side can be proved by Pythagorean theorem. It's always going to be the short side times the square root of 3. So this leg here will be the square root of 3 over 2. Same exact numbers if it's turned the other way, so that we're dealing with a 60-degree angle on the unit circle instead of a 30-degree angle. The adjacent and opposite sides just trade, so that we have 1/2 is adjacent and square root of 3 over 2 is opposite. Okay, we're now going to use this information to help us find these, which we will then memorize, just as as if it's times tables. Okay, let's start with a 30-degree angle on our unit circle. So last time we learned that in order to deal with the trig part of these angles drawn in standard form, we just take and draw a vertical line to the x-axis, and that turns it into a right triangle, correct? So if this is a 30-degree angle, we just barely reviewed that in the unit circle, if this is a distance of 1, because it's a radius of 1 in the unit circle, then the opposite leg would be 1/2, or that's the y value, correct? And the adjacent leg would be square root of 3 over 2, or that's the x value. So then if we want to find sine, cosine, and tangent, we just have to remember the rules for sine, cosine, and tangent. So sine of 30 is opposite over hypotenuse, or we learned another formula that says it's y over r. So if it's y over r and y is 1/2 and r is 1, what's the sine of 30? 1/2. We didn't do our radians for 30 degrees. Hopefully you're getting to the point where that's starting to be memorized. Pi over 6. Good job. If you don't have that memorized yet, then the way to find this would be to take 30 and multiply by pi over 180 and then reduce the fraction. So 30 over 180 reduces to 1/6. Okay. Cosine of 30 would be the x side, or the adjacent side, over the hypotenuse r. So square root of 3 over 2 over 1, which the reason for using that unit circle makes it so nice. If the hypotenuse is 1, then basically the answer is just x. It's wonderful. Okay, so square root of 3 over 2. Are these ratios going to change depending on the size of your triangle? What if you draw a triangle that has a hypotenuse of 5, and so then the short leg is 2.5 and the long leg is 2.5 times the square root of 3? Would we still end up with the same exact ratios regardless of the size of the triangle? Okay, just making sure. These are the same no matter what. These are the same numbers you would get if you plugged these into a calculator. If you take sine of 30 in your calculator, you should get 0.5 every time. If you don't believe me, you can try it. Okay, tangent. Tangent of 30 is it y over x because it's slope, right? So this one's a little trickier. 1/2 over square root of 3 over 2. Now, when we're simplifying a fraction in a fraction, sometimes we'll do the copy dot flip thing, but eventually you'll get the hang of the fact that if they both have the same denominator, then in the copy dot flip thing, they always cancel. So see how the 1/2 has a denominator of 2 and the square root of 3 over 2 has a denominator of 2. So since those two numbers are exactly the same, the denominators of the top and bottom fraction, when you copy dot flip, they will always reduce, cancel. So then we end up with 1 over square root of 3, which is not rationalized. So rationalized is square root of 3 over 3. So for our chart, we have square root of 3 over 3. Okay, let's go ahead while we're here and just flip those over, find the reciprocals of each one for our cosecant, secant, and cotangent. So cosecant is the reciprocal of sine. If sine is 1/2, what's cosecant? 2. The reciprocal of 1/2 is 2. Wonderful. Secant, the reciprocal of square root of 3 over 2 is 2 over square root of 3, which must be rationalized. 2 square root 3 over 3. Correct? Do you need me to write that out? Anyone need me to write out that rationalization? Okay. Alright, cotangent would be the reciprocal of square root of 3 over 3. But if you think about this one, before we rationalized it, it was 1 over square root of 3. So if we just remember that step and do the reciprocal of that instead, makes it easier. But you'd still get the same answer either way. Square root of 3. Alright, there's 30 done. Let's do 45. Okay, first thing on our chart, 45 degrees is what radians? Pi over 4. Alright, so let's draw our triangle in our unit circle in standard position. Here's a 45-degree angle. Here's our unit circle, so that's a 1. This is a square root of 2 over 2. Okay, what's sine going to be? Opposite over hypotenuse, or y over r. So what's the answer? Square root of 2 over 2. What's cosine going to be? X over r, or adjacent over hypotenuse, which is the same exact thing. Sine and cosine are equal at 45 degrees, which means cosecant and secant will also be equal. Okay, tangent. Remember how tangent is a slope of this line?
1.
Good job. Or another way of thinking through that is y over x, or opposite over adjacent, and those numbers are identical, therefore they reduce to 1. Okay, how do we do the reciprocals of square root of 2 over 2? So the square root of 2 over 2, if we do the reciprocal, we get 2 over the square root of 2, which is not rationalized. So we can rationalize it, which gives us 2 square root of 2 over 2. But then what happens? Those cancel. So just like the reciprocal of square root of 3 over 3 was just square root of 3, the square root of 2 over 2 is just, the reciprocal is just square root of 2. So secant and cosecant are both square root of 2. And then the reciprocal of 1? 1. Have you guys noticed that if you can figure out the sine and cosine, it's pretty easy to find everything else? So as long as you can find the sine and cosine, then you can use those to find tangent, because tangent is just sine over cosine. And then once you have tangent, you just do the reciprocal of all of these to find all of these. So as you start to memorize this, you can remember some of those patterns to help you do it. Okay, 60. What's the angle in radians for 60? Pi over 3. Let's draw the triangle. So it would look like this. I'm going to kind of pick up the pace here because we're doing the same thing. Only these two numbers switch places, correct? So for sine, we do opposite over hypotenuse, which is Square root of 3 over 2. For cosine, we do adjacent over hypotenuse, which is 1/2. And for tangent, we do square root of 3 over 2 over 1/2. Nope. Tangent would be y over x, which is square root of 3 over 2 over 1 over 2. Yeah, the 2's cancel out. You're just left with square root of 3 over 1, which is just square root of 3. Okay. Anyone notice anything about these numbers compared to these? They're just like traded around, because basically a 30, 60, 90 triangle is just that the 30 and 60 have traded places. So therefore the sine and cosine just trade places. And it's also interesting that the tangent and cotangent trade places. And then the cosecant and secant will trade places. That's weird. Sine and cosine trade places. Secant and cosecant trade places. Tangent and cotangent trade places. Does anybody remember what a complementary angle is from geometry? No, supplementary is 180. No.
Wait, they're opposite angles, like if you have like parallel lines and angles.
We have lots of different memories of lots of different types of angles in geometry. Complementary angles are two angles that add up to 90. So what do you know about 30 and 60? They add up to 90. Okay, where do you think the co comes from on sine, cosine? Sine and cosine has to do with complementary angles, because the sine of one angle is the same as the cosine of the complementary angle. Isn't that cool? So sine and cosine trade for 30 and 60 because 30 and 60 are complementary. Tangent and cotangent trade for two angles that add up to 90. Secant and cosecant trade for two angles that add up to 90. We'll talk more about that another time. That's kind of going too far today. Okay, so what's cosecant going to be? 2 square root 3 over 3. Secant. And cotangent, square root of 3 over 3. Okay, I know we did the 90 last time, but we didn't fill it in. Will you help me remember? So what's the radians for 90? Pi over 2. What's the sine for 90? 1. What's the cosine for 90? Let me give you a hint. 0 and 90 add up to 90. That means they are complementary angles. So that means if sine of 0 is 0, then cosine of 90 will be 0, because they are cofunctions of complementary angles. Tangent is undefined, yes. Okay, then what's going to happen here? Okay, reciprocal of 1 is 1. Reciprocal of 0 is undefined. And reciprocal of undefined is 0. Think about this. If tangent is a slope, what's the slope of a vertical line? There is no slope.